In this video, we're going to take a look at Chapter 5, problem number 21. The volume of a gas is 5.80 liters, measured at 1.00 atm. What is the pressure of the gas in millimeters of mercury if the volume is changed to 9.65 liters? Note that the temperature remains constant. So in this problem, we're going to approach it like we've done for so many of these other ones. So we're going to start off with our initial state here. So our initial phase, state 1, and then going to 2. So we look at, all right, what do we have? Let's start off with pressure. So what is P1? All right, so what is the initial pressure? We look at it, and it says, let's see, measured at 1.00 atm. So 1.00, and remember that pressure always needs to be, for when we're working with ideal gases, in atm. So perfect, that's good. All right, now how about volume? All right, let's see, volume is 5.80 liters, okay? Good. And then notice that it says temperature remains constant. We could always write like T1 and T1 not changing, but because temperature remains constant and we're working with pressure and volume, we know this is going to be a Boyle's law problem. So don't worry about temperature. We don't need it. Okay? Now let's look at P2 and V2. All right, and V2. All right, let's look at the problem. Let's see. Well, I see 9.65 liters, so we know volume V2 is 9.65 liters. And remember, for volume, we want it as liters, so we're good. And then, what is the pressure of the gas? And notice it says in millimeters of mercury. For this problem, first off, we don't know what P2 is, so that's what we're solving. So that's our question mark. And so now we're going to approach the problem using Boyle's law. We're going to solve for P2, and because we're using Boyle's law, the answer is going to come out in atmospheres, or ATM. And once we have that answer, then we're going to convert it. Okay? Makes sense? So let's set up our Boyle's law problem. So Boyle's law. And Boyle's law states that when temperature is constant, the product of pressure and volume remains the same for ideal gases. In other words, P1 V1 equals P2 V2. Okay? So we just now look, it's just basically substituting. So what is P1? Well, P1 is 1.00 atm. Alright, now what is V1? 5.80 liters. Alright, what is P2? That's what we're solving for, so we'll leave that as a variable. Now what is V2? 9.65 liters. Alright, so because we're solving for P2, we divide by 9.65, divide on both sides, and we end up with P2 equals, and so we do 1.0 times 5.8, which is just 5.8, divided by 9.65, and we end up with P2 equaling 0.601 atm. Okay? And notice I'm maintaining 3 sig figs. Alright? Now, this comes out in atmospheres, or ATM, because you work with ATM when you use Boyle's law, or the ideal gas law. That's how it works. So the answer asks for the gas, the pressure of the gas, in millimeters of mercury. So we need to make a conversion. So one thing this is a fact that you need to learn, that 1 atmosphere equals 760 millimeters of mercury. Just like 1 mile is 5,280 feet. So we're going to use this, and we're going to do basically our unit multipliers, or what do they call it, dimensional analysis. That's a fancy name for it, but basically we just have 0.601 atm times, and then we put 1 atm in the denominator so the units can cancel, 760 millimeters of mercury. Alright, ATMs cancel. And so we end up with 457 millimeters of mercury being our final pressure for P2. And that's our answer. So let's recap. We looked at the problem. We filled in our chart of state 1 and state 2 with our pressure and volume. we saw that the temperature remains constant, so we didn't worry about writing about temperature because we identified this as a Boyle's law problem. We then wrote that P1V1 equals P2V2. We substituted in and we solved for ATM. Well, then we saw that the pressure needed to be in millimeters of mercury, which is why it's so important to go back and read over the problem when you finish it, especially on a test. We then used the fact that 1 ATM of 7 equals 760 millimeters of mercury. We did the conversion, and we came up with our final answer of 457 millimeters of mercury. Nice job.